Hi Kickstarter, I'm Tom Grunland and I'm part of the QuickStack team. Today I'd like to introduce you to QuickStack. QuickStack is an open source embedded hardware and software platform. When we set out to design QuickStack, we had one thing in mind. Let's make it easy. Let's make it easy for the beginner that's just trying to learn electronics. Let's keep it easy for the intermediate that's making ever cooler projects. And let's not hinder the expert from making increasingly complex systems.
The QuickStack platform consists of worker boards and brainboards. This particular brainboard is called the Hello. The Hello has a hardware programmer debugger, a full-speed USB interface, some programmable LEDs and switches, as well as some optional memory. Everything is powered by a 16-bit processor running the open source QuickStack software. To show you how easy it is to program, let's plug in the debugger and look at some examples. Here we have a simple program to blink one of the onboard LEDs. We create a thread, initialize our red LED, and run a loop where we toggle the LED and sleep for 0.3 seconds. Without QuickStack, there is a lot involved to get the timing right for two LEDs at different frequencies. Things become increasingly difficult as you try to do more things. In QuickStack, all we have to do is copy our program, change the thread number, change the LED we want to toggle to green, and fill in a new time. Now we just program it and we have two LEDs blinking at different frequencies. QuickStack is truly stackable on a hardware and software level. One of the main challenges with making something stackable is pin contention. That's when two boards try to use the same pin. We've solved this problem in a number of different ways. First, we developed the QuickStack bus, a two-line bus with collision avoidance and up to 16 megabit transfer speeds. It also allows a practically unlimited number of boards to be connected to it. Here we have 8 relay boards all being controlled by a single brainboard over the QuickStack bus. Once again, the software makes it very easy to control all these boards. We open the board by its unique 6-digit serial number, define the relay we want to start at, turn that relay on, wait half a second, turn the relay off, then increment the relay until we reach the last one, and go back to the first relay. To do this on every board, we create more threads, change the serial number, and set our starting relay. Now we run and all the relays are being switched over the QuickStack bus. For things like SPIs, interrupts, and analog inputs, a bus is not always the best answer. That's why we also developed smart lanes. This is smart lane A. Each smart lane consists of 6 pins. Each pin can be used as a digital input, digital output, pull-up, open drain, and software PWM. 4 of the 6 pins are peripheral input-output pins. This means they can become any peripheral of the processor, like input captures, hardware PWMs, timers, UARTs, and SPIs. The other 2 pins can be used as analog pins or peripheral input pins. There are 4 smart lanes total. Besides smart lane A, there is lane B, C, and D. What makes these boards smart is the fact that the worker board can change which lane it uses. Even when you have 2 identical boards on the same stack, the QuickStack software will assign them to a different smart lane. This eliminates the problem of pin contention that a lot of systems have. Boards that use our smart lane, like our Wi-Fi board for example, can very easily be added to the stack and given their own thread in the code. Once again, we can open the board by a serial number, specify the network's SSID and password, open a TCP IP server on port 1100, and in this case we run a simple loop that waits until it receives something and then sends that message back twice to the sender. The rest of the interconnect consists of various power rails, a shared I2C bus, and the main lane. Each of the 16 pins in a main lane has the same great flexibility of those in the smart lanes. To start off this Kickstarter campaign, we've developed numerous boards. Some of these boards include the Hello, Relay board, Wi-Fi board, Smart Breadboard, High-Side Driver board, LED display board, Power Relay board, and Arduino interface board. Even these 7 boards will quickly stack together and not have any pin contention. You can find more information on these and other boards further down on the Kickstarter page. This includes schematics, example code, tutorial videos, and user manuals. We're very proud of the documentation and hope you have a look at it. When creating a project, often quite a bit of time can be spent putting it into an enclosure. That's why QuickStack is designed around a commonly available enclosure. The enclosure is extremely durable and waterproof. We also have our own production capability. This allows us to bring a concept to design through to manufacturing very quickly.
We really want to use this capability to the community's benefit. That's why we'll be having a running poll on our website to have you decide what we should build next.
We've really worked hard to make QuickStack the most expandable, easiest to use embedded platform out there. With your support, we can continue to expand the platform and the community.
On behalf of the QuickStack team, thanks. It's 2:30 in the morning. I'm going to bed.